Hello, this is modulo or arithmetic or mods, and this video is sort of rehashing and reinforcing what was talked about in class. So I'm going to go straight into computations with mods, and you're not going to see the system table again for mods, because that was covered in class. So this is mainly the computation with mods. How do you actually apply mods? So first of all, why do we do mods here? Or why do we do mods at all? Because it reveals something to us about remainder. Remainder is something thrown around. It's a word that's thrown around in elementary school, and then we sort of forget about it. But remainder is actually very important, a very important concept. And modular arithmetic, or mods, is heavily emphasizes the remainder. When you divide two numbers, it reveals what the remainder is, and it also shows how important the remainder is in a relationship between two numbers. So what do I mean when I say mods help us with remainder? Well, if I asked you this, is 155 a multiple of 5? You would say yes, of course, right? Because multiples of 5 are easy to spot, right? But what if I said, is 81 times 6 times 3 a multiple of 5? Okay, you might say yes after a few seconds, but it'll take a little bit longer. In mods, it would take about the same amount of time to answer this question as it would take that question. Plus, mods can also answer the following question. If it's not a multiple of 5, then it also can answer the question, how far away is it from being a multiple of 5? In other words, what is the remainder if you divide it by 5? Because the remainder tells you how far the number is from being a multiple of 5. For example, if I take 17 and I divide by 5, I get a remainder of 2. So no, 17 is obviously not a remainder of 5, but we do know from the remainder that it is 2 away from being a multiple of 5. It's close, it's 2 away. And that's what mods tell us as well. Okay, so I'm going to go ahead and show you the clock for mod 5 that was shown in class, just as for a reference in case we need it. And so, as I said before, you can take any number like 6 and use the clock to find out what value it is in mod 5. So I start at 0, 1, 2, 3, 4, 5, 6, which tells me 6 is equivalent to 1 in mod 5. But what does that really mean? Well, I was just talking about remainder. So this 1 means that 6, when divided by 5, gives you a remainder of 1. Or in more normal people's language, it is 1 away from being a multiple of 5. It's 1 away. 23, it's 3 more than 20, so 23 is 3 in mod 5. In other words, it's 3 away from being a multiple of 5. And these are all single numbers, so it's pretty easy to find out what it is in mod 5. If I have the clock, I can just go around, but if I have a larger number, then going around the clock is impractical. So to find out what it is in mod 5, I can resort to long division. That would be a remainder of 4, so I know 99 is 4 in mod 5. Now these are all single numbers, so I have the clock or I have long division to lean on. But what if my expression is not just a single number? Maybe it's something more, like 16 times 6 plus 18. What is that equivalent to in mod 5? So I have a couple of options here. I could find out what 6 plus 18 is, that's 24, then multiply with 16, and I'm going to get a rather kind of large number. And then I can do the long division with that large number, and then find the remainder when I divide by 5, and that will tell me what it is in mod 5. But in mods, we have more flexibility than that. I don't have to compute this whole expression, because this expression is also equivalent to this. Now, how did I do that? Well, what I did was I converted each of the numbers in the expression in mod 5 separately. So 16, that's pretty easy. It's 1 more than 15. So 16 is 1 in mod 5. 6, 1 in mod 5 because it's 1 more than 5. And 18 is 3 in mod 5. And now I just work with this expression with much smaller numbers. 1 plus 3 is 3. 3 times 1 is 3. So the whole thing is 3 in mod 5. So I can say that the original expression, 16 times 6 plus 18, is 3 in mod 5. So when all is said and done, if I work this whole thing out, I would get a number that is 3 away from being a multiple of 5. It's just 3 over. 3 more than a multiple of 5. That's what it's telling me. Okay, let's switch to a different mod so we're not thinking that all of mods revolve around mod 5. Let's turn to mod 8. So if I have, say, any product that has 8 in it, this is obviously going to be a multiple of 8, right? Because it's one of my factors in the product. So that's going to be 0 in mod 8. If I see a product but I don't see an 8 in there, well, I still have the factors of 8, 4 and 2. That makes an 8, right? So that is also 0 in mod 8. So it's something to keep in mind. If I have 8 raised to any power, let's say 8 to the 43rd power, that's going to be gigantic, right? But I still know that it's going to be a multiple of 8, so that's also 0 in mod 8. Now if I have a sum, now one of my addends in the sum is 8. Does that mean that the sum is going to be a multiple of 8? Is that also going to be 0? Maybe, maybe not. What I can do is I can replace this 8 with a 0, right? Because I know for a fact that 8 is a multiple of 8. So 8 is equivalent to 0 in mod 8. Now these numbers are all less than 8, so I can't convert any of these. Or can I? I can say that this is 13, therefore this is 5 in mod 8. I can say that this is 9, so that's 1 in mod 8. 3 plus 2 plus 1 is only 6, so I can't really do anything with that. So I'll just leave it as a 6. But then I can add these, and I get 12, right? 12 in mod, so I get a grand total of 12, and 12 is small enough that I can do this in my head. 12 is 4 in mod 8. Okay, so in any expression, any part of the expression, I can convert. Any multiple of the mod, I can convert to 0. Anything that's bigger than the mod, I can convert it, like I did this 13, I can convert it to 5. So you can convert separate parts of the expression before you start computing. One thing you can't do is convert exponents. For example, if let's say I'm still in, let's go back to mod 5. So we're back in mod 5. So I have 5 or I have 7, and I'm going to raise the 7 to the 5th power. I want to know what this is in mod 5. Well, I can certainly change the 7 to a 2. How about that 5? Can I change that 5 to a 0? Because 5 is 0 in mod 5. No, I cannot change this. Why not? I can't change this because I'm not actually computing with this 5, am I? I'm going to compute with this number 7. I'm doing 7 times 7 times 7 times 7 times 7. But nowhere in there am I saying times 5. I'm not doing anything with a 5. The 5 is just an instruction. It's telling me to write the 7 down 5 times and multiply. So if I'm not actually computing with the 5, why should I be able to change it into mod 5? No. So exponents cannot be touched. They should never be touched. So this, I can change it to 2 to the 5th power, but I cannot change it to 2 to the 0 power. And so this is 32, which is 2 in mod 5. Okay, so there's some tidbits about mods. Enjoy them. Bye-bye.